Hey, this is Barnaby, and today we're going to learn how to do electron configurations to say where the electrons are in any element. So it helps if you draw on your periodic table, so go ahead and take that out. And then we're going to label it so that helium is moved over to the left. The first two columns are the S block, that's the elements that end in S orbitals. The middle ones, the transition metals, are the D block, the ones on the right are the P block, and down at the bottom we have the F block. And then see the numbers on the side of the periodic table, or if yours doesn't have them, fill them in. Let me go back for you a little bit. So on the left there, the rows are the energy levels, 1, 2, 3, 4, 5, 6, 7. And that's the same numbering over here in the P block. In the middle, the numbers drop down more. So this first row right there, with scandium and titanium, that's 3D instead of 4D. And then the Fs, which come right after the first D, if you look at the numbers on the bottom, you'll see how CE is number 58, so it goes right after LA. The Fs are 4 and 5, so they drop down 2 energy levels. So you need to be able to look at this and figure out the order that orbitals fill in. So if we just read it left to right, it goes 1s, and then 2s, 2p, 3s, 3p, 4s, then remember to drop down 1, so it's 3d, 4p, 5s, 4d, 5p, 6s, 5d, only one of the 5d comes there, and then you go to 4f, the rest of the 5ds, 6p, 7s, and then 1,6d, the 6Fs, the rest of the 6Ds, and then it turns out there aren't any 7Ps in ground state. So that's the order that they fill in. That's the most important thing about being able to do these problems, because it's kind of a funny order, but as I just showed you, practice using the periodic table to figure out the order of any element. So let's practice with zinc. So orbital notation is where you draw arrows to show the electrons. So if you just look on your periodic table, the order for zinc, starting at the top, reading left to right, top to bottom, goes 1s, 2s, 2p, 3s, 3p, 4s, 3d. And then you just fill in arrows which represent electrons for each one. When you do these p orbitals that I'm on, each orbital of equal energy gets 1 before any gets 2, like that. Same thing with these 3p's, same thing with these 3d's. And then I wind up filling all of them up in the 3D, because when you look on your periodic table you see that zinc number 30 has 10 3D electrons. I highlighted the 4 S's because I wanted to tell you those are the valence electrons. Electrons in the highest number are the highest energy level. So arrows are orbital notation. If you just do regular electron configuration, that's with superscripts. So instead of 1s, 2 arrows, you use superscripts 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. And noble gas notation is the most abbreviated way. To do that, you put in brackets the previous noble gas. So zinc is number 30, count backwards until you get to noble gas, and it's argon, previous noble gas. So that would be just argon, 4s2, 3d10, done. Brackets argon means electron configuration of argon. So you've taken care of 1s2, 2s2, 2p6, 3s2, 3p6 just by saying brackets argon. Hope that helped.